So it's the final seminar of the series for this year, and we're delighted to have Dr. Flávia Santos. She joined us this year, and she's going to present kind of an overview of the research in developmental dyscalculia. So Flavia's done a lot of work in this area, so we're all really looking forward to it.
Thank you. Good afternoon. It's a great pleasure to be here. Thank you again for the invitation and the opportunity. And we are going to talk about developmental dyscalculia, considering different aspects. So I will start saying about the number development, so the systems we have. Then I will present overall information about the developmental dyscalculia. After that, I will show 4 studies on us. And then I will open for questions. But of course, if there is any specific question regarding to what I'm saying, just please interrupt. So I'd like to start in a more interactive way. That's how I like it. So I have 2 questions for you. And I would like to show you 2 sets. And I want you to let me know which one is the larger. Anyone or any 2? Don't be shy.
Right.
Okay, and 1 and 2. Okay.
Same.
Sorry?
Same.
Same. Other different opinion?
Same.
Okay. So another question I would like to make is this one. How many objects we can see in this image? So, any guess this side?
50.
50? 60?
42.
42. Yes, all nearby. That's good. They are... Okay, so I chose these 2 questions to show you that we have one system that we can share with other species, like baboons, and this is the cardinal system. So even if you ask for the baboons, choose the larger, for instance, showing a pair of amounts, like 2, 4, 3, 6, etc. They systematically go to the larger one very fast, and even above chance. So that's something that they can do for the first exposure, so without training, they succeed to do that. And if you do a training and try to compare, for instance, when you do a sequential presentation, like 1, 2, 3 objects, or take the 3 and put all together, they still performing above chance. So definitely they have these skills like we do, we all do. Now I would like to mention another system that's unique for human beings, that's at least apparently. And we used to think that children start to learn about numbers when they say 1, 2, 3, 4. They learn by heart and they repeat it very nicely. But actually we are learning about quantities and amounts very earlier. When we listen to words like a little bird, a big dog, lots of stars in the sky, a few flowers in the garden, you've got 3 wishes, or you go first, I'm the second, he's the third. So this system is very important. And a good example of this is that when you're looking for children with hearing loss, they tend to have a delay on development because of later opportunity to learn language or to acquire language, sign language or speaking. The third system we achieve is the symbolic one. So we start to use Arabic forms in our culture. Other cultures would use, for instance, Roman numbers. And we also think that the child learns this system when they say that the Arabic form represents the word we name it to. But actually, it's more important than that. They must perceive that other words like pair, both, double, etc. represent a constant same amount every time. And we can use also gestures or sign language properly to represent this system. Now, if we think about the need of measuring, especially in architecture and other areas, we know that different civilizations have been using it in different ways. So in the past we had the span, the foot, the cubic, and we know that if you find people with big foot, you probably will have inaccuracy on your measures. So nowadays we definitely need something more strategic to use. So, but again, we think that we start to learn about ordinal system when you go to school and receive a rule and say, oh, this is 30 centimeters. So that's our idea of metrics. But if you think, we have other opportunities in life since the very beginning that show us like this. If you remember when you were small, your parents put on the wall your numbers and the risks relating to your height, your age, and so you start to learn that the numbers are sequential, ordered, and increase in amount. So nowadays we have a more sophisticated metrics which allow us to look at those maps and say, choose the larger again, and we know that by this metrics we can say that Brazil is far, far bigger than Ireland and probably has far more problems than Ireland. But the important thing here is that we developed this number line system, this number line understanding of numbers. Okay, so now we know what are the systems, and we can consider how they are organized in time. So at the beginning they are very separate, because the child will acquire them in different moments of the development. But with aging, experience, and schooling, they are becoming more and more integrated. And when they are very integrated, then we have this ordinal system, this mental number line. The point is, what if numerical number systems do not develop accordingly? That's when the problem starts. So here we have numeracy deficits, when the child comes with an F grade, and everybody said. What's important to understand is that failure has a long-term outcome and very negative impact in society and for the individual. It undermines economic, social, and psychological outcomes in adulthood. For instance, low achievement in maths is associated to depression, trouble with authority, lower occupational status, and lower incomes. So definitely it's a huge problem, a serious questions to be taken into account. Well, in English, a double negative is bad, but in math, if we have a double negative, for instance, minus children with low achievement and minus children without proper intervention, then we probably will be having sustainable developmental goals. So we can consider that improving maths, we can help with poverty, no poverty, good health, quality education, gender equality, decent work, and also reduce inequalities. So it's something very important. But to do it, we must really know what we are facing. So, difficulties in math. That's a very general expression. We hear this from parents, from teachers, from researchers, from everybody. But what's difficulties in maths? We cannot look at them as a unique thing. They are separate situations with different outcomes. So it's very important to just separate them. So we could say that we have at least 3 major categories. One is developmental dyscalculia, as I strategically show you that is the small group. Then we have calculia, and we have low achievement in math, which is the most frequent thing overall. Acalculia is really related to brain injury, so it's the case of a child who borns healthy, develops well, go to school, learning maths, do well in maths, but suddenly had a brain injury, and after that loses this ability or changes the way to use these abilities. When we see a different pattern, like mild, transitory, and eventually spontaneously lapsed deficits, then we are talking about extrinsic causes like class absence, inadequate teaching, fatigue, if the child has another disease, or if they are low income. So in those conditions, we probably will have low achievement in math, which is different from developmental dyscalculia, which is actually an intrinsic cause. Let's say everything surrounding the child is fine, but the child cannot learn. So in these cases, we might see severe, persistent, and resistant to intervention deficits. So this is our target from now on. So how developmental dyscalculia looks like. And I think it's important to have some empathy. So I chose this image to make a metaphor about this. So imagine a child going to school. She's in class, she's very, very clever, she wants to learn, she's there, focused, and like us, we can, as far as I know, there's no physicists here or mathematicians, right? So the child will go to the class, she sees numbers, she is able to see that there are symbols. The symbols are related to the numbers, and this interaction produces another number, which is another amount. But what to do with this, or this, or this, or this? That's the feeling. You look at the numbers and you don't know what to do with them. So developmental dyscalculia is a heterogeneous disorder resulting from individual differences in development and function, with neuroanatomical, neuropsychological, and behavioral levels, affecting them in an interactive way. We also have another term to describe it, which is mathematical learning disabilities. So they are used for some researchers as interchangeable terms. There are some questions, but in overall they are equivalent. So what are the characteristics of a child with developmental dyscalculia? They have number deficits and calculation deficits. So for number deficits, we can say difficulties to transcode, like pass from verbal to from cardinal to verbal, for Arabic, and so on. They have difficulties to count in backwards. They don't know how to play and to use the place value system, and they have problems with mental number line. Another characteristic is the use of immature counting. They use the fingers to make a counting. They are very limited in retrieval. They don't know how to take advantage of decomposing in order to facilitate complex problems. And they have several problems in calculation procedures. For instance, I put here some examples. Here, the child misses the spatial aspect, so that's the problem. Here, although the counting is correct, 14, but there is a memory failure, forgot to carry, and so on. In this study, they were seeing children from 11th grade, and it's impressive that at 11th grade, they have difficulties to make 7 times 8, or 45 divided per 3, and fractions and more complex multiplications. Another characteristic that we can see in children with developmental dyscalculia is slowness. So if we're looking at this line, horizontal line with black dots, we'll see that in overall, a child with typical development takes around 1,000 milliseconds to respond when we compare numbers between 10 and 99 to 55. But children with developmental dyscalculia takes longer time, especially between 6 and 98. They take longer time, so they are very slow to respond. Another important aspect about developmental dyscalculia is that there is an early onset. So here we have the 3 curves, and the controls clearly show an increase with time. So from the kindergarten to the 3rd grade, they score much better in maths. But when you're looking at children with developmental dyscalculia, the first point is here. Kindergarten, they are very, very low. So, in fact, we should think about assessment and diagnosis very early in time, looking for these children. And then, in terms of curve, we see more a plateau or a decline according to different studies. So it's very important to looking at it very early. Another characteristic is the persistence. So in this study, they did a 6 years follow-up, and 4% of the sample still having difficulties with math, which were associated to lower IQ, attentional and written disorders. Genetic factors. So the first we can mention is inheritance. So if you ask parents about their past, how they manage maths, they usually say they also had difficulties. And also brothers and sisters of the child with developmental dyscalculia, they usually have difficulties with numbers. But when we're looking at twins, if one twin has this developmental dyscalculia, the other twin probably will have difficulties in maths as well. And in fact, monozygotic twins are 12 times more likely to have developmental dyscalculia than the general population. And finally, we have evidence from syndromes like Turner syndrome, where it's a clear association between impairments in arithmetics and parieto-occipital dysfunctions. As for neural substrate, I selected just a very simple example. It's a task of approximate calculation, like 3 plus 8, and the person must choose which response is the nearest, so between 10 and 5. And in this particular task, we can see that children with developmental dyscalculia usually presents all intraparietal sulcus, all medial frontal gyrus and inferior frontal gyrus bilaterally, low activation in those areas. So definitely we see a brain dysfunction. Another interesting characteristics that we can see in children overall, but especially in children with developmental dyscalculia, is maths anxiety. So, for instance, in this study, they compared 8 years old children in 3 groups, and they could see clearly that between children with low achievement in maths and children with developmental dyscalculia, there was a they presented higher scores in maths anxiety. So it's an important combination. And in this study, I had the opportunity to collaborate. In this study, we're looking at neuropsychological and neuroimaging results of children with typical development from 7 to 12 years old. And we saw a clear association. When there was a high level of maths anxiety, there was a low performance in attention, working memory, and maths achievement. And when we're looking at neuroimaging, it has a clear pattern as well. And so the voxel-based morphometry showed that there was when we could see high maths anxiety, there was a low activation in gray matter volume. There was a reduced volume in gray matter in these areas. Intraparietal sulcus bilaterally, cuneal cortex bilaterally, and lingual gyrus on the right hemisphere. As for diagnosis, how we can do that? We certainly focus on ICD-11 and DSM-5. So we have 5 key elements. They are discrepancy between measures of intelligence and maths, so must be really discrepant. Low scores in standard measures of numerical cognition, so you really must use the standard measures and use clear cutoffs. Academic skills quantifiably below expected for age, so usually in children with developmental dyscalculia, you expect, for instance, the child on the 3rd grade, but this child is performing like first grade, so it's a clear delay on development. And resistance to intervention. So for instance, in that 6 years follow-up I mentioned before, children, of course, after diagnosis received treatment, pedagogical treatment, but they didn't improve. So conventional treatments are not effective in this case. And the persistence of symptoms across time is another way to see it. So when we're looking at those different criteria and looking at epidemiological studies, like in this review, 17 epidemiological studies, we see a variation across studies, but when we filter better the percentiles and z-scores, we see that the prevalence is around 6.5%. And it's very important to say that the prevalence of dyslexia is quite similar, but there's no the same attention from teachers, professors, researchers, families regarding to this question, because people tend to think that it's normal to be bad in maths. Okay, so that's another aspect to be changed. That's the view of maths in different societies. And then the types of developmental dyscalculia. We should describe it at least in two major categories. So primary DD and secondary DD. Primary developmental dyscalculia is the child who presents exclusively deficits in maths, so no other difficulties in the process. But for any other combination, we call it secondary DD. So you might have comorbidities like ADHD and dyslexia and other disorders, neurodevelopmental disorders, or when the child don't have it but presents deficits in cognitive functions like working memory, attention, visual spatial, and so on. So it's very important to say at this point that you don't have a unique pattern of behavior and cognitive deficits in children with developmental dyscalculia. They are very different. There are several combinations.
Can I just ask for a minute?
Yes.
Do children with the primary dyscalculia, do they have to not have a deficit in working memory?
Exactly.
Yeah.
To be primary developmental dyscalculia, you must have exclusively problems in quantitative and numerical systems.
Yeah. So
all the other functions are perfect.
Because all the others you could actually explain it as
yes,
working.
Exactly. Exactly. So what are the interventions we know for developmental dyscalculia? We have target on mathematics, behavioral and psychological, non-invasive brain stimulation, pharmacological, and multi-component, which is a combination of the others. Keep in mind that because developmental dyscalculia is heterogeneous, you really must looking at the profile of the child to decide the intervention. And keep also in mind that this is a very new area. We have around 15 years of research in developmental dyscalculia, so the interventions are very new and need to still being tested. So what we know so far is that they have problems like small sample size, non-random size, and even sometimes even control group. So keeping it in mind, I would like to present my research, some of my studies in this area. And the first one I would like to mention is non-instrumental musical training for children. So non-instrumental here means clearly that the child don't go for the musical training to learn how to play piano or how to play guitar, but they use the body, the voice, and other elements to learn maths or learn anything related to music. So this study was published in 2017. In this study, we use prospective, case control, double-blind, quasi-experimental design, and our intention for analyzing the data was to use cluster analysis. So we did cluster analysis on the pre-test, and we did a cluster analysis on the post-test, keeping in mind the two groups we had. The case, which is developmental dyscalculia, and the control, which are the children with typical development. So in the pretest, the cluster analysis found those subjects, and it fits perfectly when we're looking at the neuropsychological assessment. So it was a correspondence, perfect match. They did the musical training, which was composed by 14 sessions of rhythmic and melodic activities. They were performed in small groups and once a week for 60 minutes. The results post-training are very interesting. When we look in the sample size, we see a change in both groups, in that 8 children which initially had deficits in maths normalize their performance and become part of the control group. So that's the main result. And when we're looking at performance per subtests in maths for controls and developmental dyscalculia, we can see the asterisks, meaning where the changes appeared. And the only difference I will mention in special today is this one. So children with developmental dyscalculia improved from pre-test to post-test in this task, which is a task that represents mental number line, because it's they must position numbers in this analog scale, and they succeed and improve this quality, this task qualitatively as well. Second study. So here we see a different name. It's Numerical musical training. So it is musical training without musical instruments, but without playing musical instruments. But there is this numeracy in the beginning, means that we designed the training considering the 4 systems of numerical cognition. So it's very well structured in this sense. This study was already published, and here we were working with 5-year-old children, and we divided them in 2 groups, control and experimental. The study was, so the allocation in the groups was pseudo-randomized and blind, and control did the business as usual, so only classes, and the control did the training. And the training was composed by 8 sessions, 40 minutes, with 3 activities each, like melodic, rhythm, and pitch. I'll give a few examples. So for melodic, they had to sing songs, and we chose of course songs with music, with numbers. So like 10 little angels, angel boys, and they had to do the symbols every time to become aware that the word was related to the number. So they like to say 10 little angels and so on. And this speech task was very funny. They could see 2 pictures, and we teach to them that the animals do sounds. They know that very well, better than us. And we ask them to understand that when the lion does roar, roar, it's very bass, and the bird does very pew, 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 pew. It's very trivial. So we start to play with different animals and different sounds, and they have to classify it. And in more later on the process, they start to realize that they could have going up and going down in treble and bass. So after that, we use musical notes, piano sounds, and they had to do the same classification for us. And then we have the rhythmic task. This is only one of the rhythmic tasks. So we explain to the child that all words have sounds, and actually we were meaning syllables, but we said sounds. And then we ask, how many claps you do to the sun? And they spontaneously would give their answer. After this, they say the answer, appears a dot. And because their answer was correct, then after that appears the number in numeral in paragraph form. It was the same for different elements. We had several other pictures. And another task was very important in the program is we had addition and subtractions, and they had to do the gestures. So like here is 1 plus 1 equal 2, or 2 minus 1 equal 1. And they learn to do that, and of course they have to clap every time because it's a rhythmic task and everything. So the results, we got what we exactly wanted, a near transfer. So they improve in counting and addition and subtractions after training. But we also had a far transfer, which was an improvement in phonological memory. So it was very nice. And just to give you new information, we received a response from Annals of Psychology that we had another study accepted. In this one, we had children with developmental dyscalculia performing the same training, and they had improvements in maths, improvements in memory, plus improvements in maths anxiety. So that's something we are very happy with this result. Study 3. So here we had a computerized intervention. And this is not published yet, it's very new results, we're still working on it. And we hope to present in the Mathematical Cognition Learning Society later this year. And in this study we have the Calcularis, which is a Swiss program that has 17 different tasks, and all of them related to maths. So we did a 3x2 RCT study, so 3 groups and 2 times. We did the entire study, so first we did the screening of 888 children to find 66 which had developmental dyscalculia, and then we allocated the 3 in 3 groups. The first group is the adaptive, the one who received the Calcularis, as they should do. The second group really had no training, so it's the business as usual. And the other group received a no-adaptive version, which means like a sham effect. So they had the task, they had access to the training, they had all the sessions, but without increasing in difficulties. So we had 20 sessions, 20 minutes per session, 5 days a week in small groups at school. And these are examples of tasks related to the program, so addition, line, and stimulative. And these are the results, very summarized. The important thing is the untrained group didn't improve, as expected. And when we're looking at the results, we see that for oral word problem, oral number comparisons, the adaptive group improved from pre-test to post-test. And when we're looking at subtraction, both groups, adaptive and no-adaptive, improved from pre-test to post-test. We also found far transfer for phonological memory and shifting tasks, but we didn't find any difference on maths anxiety for this problem. Now the last thing I would like to mention very quickly is the research I'm doing here in the last 5 months, which is the time I'm working here so far. So I have 3 projects, and I will mention just this one in gray, which is maths performance, child and praxis perspectives. This study is based on growing up in Ireland, and I must make a very special thanks to Alan because it was his idea to looking at this data, so thank you so much for suggesting it. So as you all know, the Growing Up in Ireland is a national longitudinal study of children in here. You have two major cohorts, and I will mention just the child cohort, the one I've been looking at so far. So we, in this cohort was assessed at age 9, 13, 17, and 20. And the initial cohort had 8,500 children. So what are we doing with this data? We select maths performance, maths scores, and we are looking at this data in comparison to different variables, and we did 6 different regression analyses so far. So one is related to socioeconomic factors, the other developmental risk factors, relationship with parents, proactive activities, efficacy and expectations, and the one I will present today is regarding bullying. Just for the record, all of them are significant, so it's very, very nice. But about bullying, what we find out is that 37% of the children present any kind of report regarding bullying. So this is something very important. For me, it was shocking to know that. I think it's a lot. And most of them are verbal. At the time, 2007, 2008, perhaps was too soon to see electronically. Perhaps if we do it now, if you see the new cohort now, we'll see higher levels. And the report of parents were in the same direction, but with lower rates in all cases. And in Duncondra, they had a performance in maths with percentage about 56% of correct response. Notes that only one child was out of these results. And what is the module? So we did a multilinear regression module, considering the report of bullying by the child, or the report of parents regarding chronic illness and socioeconomic, social-emotional difficulties, and we select as dependent variable the scores in maths. So the results are summarized here, and they show us that the parents' report was significant for strengths and difficulties questionnaire, and also physical, electronic and written bullying were also related to maths. So this is what we are now working on to prepare the first article. And just to summarize what I've been showing you about our research, so early diagnosis and early intervention seems to be preventive and very important. Brief interventions work and might be useful for near and far transfers. Interventions with mixed groups are very good for socialization, for inclusion. Calcularis promotes improvements in maths performance. Musical training improves maths performance and maths anxiety. And policies should be targeting both protective factors and vulnerability factors like bullying as well. These are my collaborators, my Brazilian students, and Professor Michael von Master, which is the author of Calcularis, Roy Cohen-Kadosh, which is from University of Oxford, and Luis Fuentes from University of Murcia. And I couldn't finish it without making a special thanks for Doreen Murphy from University of UCD and from Ireland, which is my first collaborator here. So I'm very pleased with the results we've got so far. And thank you so much for your attention and your time.
I'm interested in the connection of bullying. What do you think relates maths to the higher likelihood of people? Is it self-esteem? Are there comorbid kind of learning difficulties there? What do you think kind of drives that relation?
Well, it's very new for me as well, so it's not my key point yet. But what I see is that you saw difficulties on the SDQ, and the SDQ has several questions regarding different aspects like depression, anxiety, socialization, and everything. So you have a combination of different elements, and I believe that if the child has any of those, they might be in trouble. And bullying, definitely, it's very important because when you think about maths anxiety, one of the key elements of maths anxiety is that the child is there. He or she should be looking at the calculation that she's doing, but in fact she's thinking, oh my God, my colleagues will see that I don't know that. Oh, my mother will kill me because I cannot do it. My professor thinks that I'm stupid. So definitely, if you have those kind of thoughts interfering on your performance, they will really disturb the results. So I think that's the first.
Thanks, Flavia. I love the talk. I was really interested in musical training. So, I know that, what's the impetus for musical training for dyscalculia? Because I'm thinking of dyslexia, and they have a rhythmic intervention for dyslexia. And is the underlying mechanism related to temporal discrimination? And do you know if there's some kind of way of connecting the two there?
Yes, there are several things. I just couldn't put it because it was already too long. But, just to... What are you doing? Is this one? Okay. All different theories that I could explain to you about the connections between music and maths. But one of them, if we think about really the classic, if you go directly to Pythagoras, he has the harmonics, which is this ratio that makes that you really see proportions on sounds, and they are connected in time, and so that's an element. But we have other elements like the 4E cognitive science, so the fact that the musical training is really embodied, embedded, and inactive. So these are elements that helps. If you consider this other theory that says that it's essentially multisensorial and multimodality. You are all the time works with verbal, with auditory, with visual, so you are working with everything all the time, so it's very multi-sensorial.
It just seems like, I wonder if children who have dyslexia and dyscalculia, and those who just have a unitary impairment, do they all show temporal discrimination issues? Do they all have an issue with rhythmic?
Yes.
It's like a physical test of rhythmic perception. This would be a nice link there to see.
Yes.
That's one of the main underlying kind of reasons why.
Yes.
Exactly.
And in fact, there are some neuroimaging studies showing that you have, of course, different activations, like I was saying, for maths concretely, when they are doing calculation.
Right.
But when we compare the brains of children with developmental dyscalculia and the dyslexia, they are pretty much the same. Okay. So definitely something very intriguing in there. And if you go for genetics, they say that you have the theory of combined genes. So you don't have a gene for mathematics or a gene for reading, but the learning itself has shared the same genes. So definitely you must have connections in that.
Yeah.
No, I did a piece of research here in UCD and for my doctorate, and I did it on dyscalculia.
Oh.
And I did a lot of work with Brian Butterworth's theory of the number module deficit. I'm just wondering, what is your view of his dyscalculia screener, which is what we would present to teachers to use to screen for dyscalculia?
Yes, it's a computerized test.
Yes.
And I think the great strength of this battery is exactly that you have some tasks which are time controlled. For instance, we use this German battery, which is Numerical. And I think in terms of covering all development aspects of numerical cognition, Numerical is better. It's more detailed and complete. Numerical.
Okay.
But in other, I have this one.
And is that computerized?
No.
No, that's kind of...
That's the only thing I was going to say that I consider not great, is that Numerical is not controlling time of performance. But apart from that, I think it's more complete and more comprehensive. I don't know yet. I'm looking for this information as well.
Yeah.
I hope so.
But Ryan Butterworth's theory, you would agree
definitely.
with the subitizing and
Yes.
Yeah.
Yes.
Yeah, fascinating. Absolutely brilliant. Thank you.
Thank you.
Thanks, that's really, really interesting. I'm also really interested in the musical interventions, which I think to me makes perfect sense. Maths and music have a lot in common. Have you any plans to try and integrate those interventions into Irish schools, and do you think they should form part of the special education curriculum for children who have difficulties with mathematics?
I would love to do that. I just wanted the opportunity. Yes, definitely. And one thing that I would like to say about the musical training intervention that I think it's very important. We did the study thinking of a third world country, a developing country. And when we did this, we knew that they didn't have the musical instruments to play at home or to go to a school, so it had to be inside the school, inside their schedule of school. So could be something that would be easier for the school as well. So we have a musical educator at school, so they could have access to this person, and that's why we chose this way. Apart from that, we believe that if you do intervention in groups, you save time in some aspects, but you gain time in the sense that the child is interacting with others. It's very complicated nowadays. The tendency is to say, oh, you must do an individual intervention. So you put the child in the chair and she's on the spot and she thinks that she's the problem. But when she's playing with other children, she feels much more confident and more happier. And apart from that, music brings happiness for people. So
and also, if you make it an individual thing or you have it relating to it being at home, then you start to have issues of class and finance, that the children whose parents have the money to buy a musical instrument or to get extra tuition, that they get helped and the kids who don't. Whereas having it integrated into school means everybody gets the same as
exactly. So I think that's something that I really would like to see, this kind of intervention available in Ireland. And I believe that we need to do more research in the sense that we need to have larger samples. Mine, I did all the controls, make sure that I had used power to see effect the sample size. So I know that I had power to make the assumptions I did, but still we need more replications. I have only 2 replications in my method, so definitely need 1 more at least. But I hope so. Yes.
Thank you, that was brilliant. I'm just wondering about the long-term effects of any of the musical training. Is there any research?
Thank you so much for asking that. This is a paper who is waiting for reviewers. We did it. We did especially this second study, not the first study I presented. That goes too slow. But we did the assessment of the child, pre-test, post-test, and 6 months later. And we found that the results were persistent, at least for 6 months. It's this study here. This study, we did a follow-up. So we are waiting for the publication now. She knows about it. We put it's a topic on frontiers, so it's there being assessed. So hopefully, until the end of this year, it will be published. But yes, there is a persistent effect. So it's very important because usually when you use an intervention for children with developmental dyscalculia, or don't work at all, or doesn't work at all, or the effect disappears with time. So hopefully.
And is there any work done on older children, like musical training for older children, where the maths gets very difficult?
No, as far as I know, I haven't heard any study about this, but it would be very interesting.
So just linked to that, actually, sorry, I just do you think that the intervention at this stage would level the playing field? So, like you're talking about, say, 5-year-old children there. Do you think that, so what Clean is talking about is, you start doing, calculus and things, and
yes.
When you're in secondary school, and it's very abstract. It's not about counting; it's very abstract kind of maths. Do you think this kind of training would allow students to be able to handle that, or would it only help with the low-level kind of arithmetic kind of?
Well, what I could say without any study is that if you do this training, the child will help. The training will help the child to automatize arithmetical facts and mathematical thinking. They will be faster on their thinking. So probably it would help in this sense that they would see a huge calculation and be able to do parts of that quickly. But not necessarily the child with developmental dyscalculia has problems to have the mathematical thinking. They have much more problems with arithmetics, so probably would work.
That's right. Okay.
Yes.
Very nice talk, thank you. Could I ask you just maybe to say something about the age of this disorder? I'm most interested when someone says this is a neurodevelopmental disorder.
Yes.
And if you look at, say, the 1850s, I think it was estimated that 85% of people in the world, adult in the world, couldn't read, so obviously dyslexia didn't exist. When did dyscalculia come to be defined? And I suppose, have you any broader ideas on brain evolution or brain development that makes us somehow describe this as a disorder today?
Well, we follow really the standard criteria from DSM-5 and IC-11, so definitely we are following them, and the child, the behavior and the cognitive performance fits on the criteria. So we could say that it is. But there's a huge discussion, including Butterworth. I remember a memorable moment in 2008 when we all were in Oxford. There was this meeting of Mathematical Cognition Society, and we were discussing exactly this. Because if you have this cardinal system that is shared with other species, and we consider that innate, so we are thinking that the abstract part of maths, it's something else. But if we understand that maths is a construct that really needs schooling, then it's a different understanding. So we really have this problem nowadays to define if it's. I still think that is innate, in the sense that we can see clearly in preschool children, even 9 months, I didn't show, but we see studies showing 9 months babes, and they have this sense of numbers. So definitely, I think it's innate. So
I guess it gets back to Fiona and Kira's question. I mean, number sense may be something a lot more basic that has to do with counting rather than
yes,
the abstracts of
exactly.
mathematics, which is a huge thing, and we kind of enforce it on children in schools.
Yes.
Flávia, obviously parents do a lot of the teaching as well. It's not just in schools, but parents are responsible for bringing on the children in their abilities. And I'm just thinking one of the strengths of growing up in Ireland is that it gathers data not just from the children, but also from the parents. I'm thinking that if, for example, you could show that there's a strong, independent amount of variance explained by parental educational attainment, and if, for example, you could show that very low parental attainment is associated with children's difficulties, say with maths, might there be an argument to intervene with parents to try to improve their skills so that they could translate that into children's skills?
That's a very nice comment, and reminds me something that they asked me to write on this conversation about exactly this piece, the fact that parents don't know how to help children in maths. We know that there is a very strong stimulation in society when the child is starting to learn words. So you show the child, oh, look at the letter D, look, the word love, I don't know, anything. You are always stimulating for knowledge of how to learn and how to read. But you don't do the same with maths. And so definitely the analysis we did showed that if hours of homework are related, if the child goes for this group work for, I forgot the term because it's very unique from here, I never heard about this, the groups that when children can, club, I think it's club. Yes, exactly, this one. So they have a space for learning, and apparently it's, I wouldn't like to say much because I didn't go further in the analysis, but apparently it didn't help. So definitely we could give better advice for parents and work on policies to give education for parents. I'm not sure if it's kind of intervention in the real sense, but psychoeducation would be very important for parents in the sense.
Do you think the early playing of games, kids don't do as much now as they used to, like snakes and ladders, Ludo, hopscotch, involving numbers? Do you kids are missing out now because they don't have that early experience of number
I do.
compared to before?
I do.
They're counting kills in Fortnite.
Ah.
Kills.
I do, and when I was asking to prepare the front of the book, I asked this precisely. I want this game because I think it's so clear. The child has the contact with numbers all the time and see the relationship between numbers and playing together. So definitely I believe that if the child has experience with space, especially space, regarding maths, that's very visual spatial. So if the real sense of the space is very important for learning maths.
So then I think the moment listening would like this then too. Is there scope, considering that spatial element, is there scope for like a dancing intervention that might?
Yeah, actually there are
Because
studies.
dancing involves counting, and obviously I won't bring it back to dancing. Right? That's the number 8 though. Exactly, but you know, but there is, but there is and like rhythm and numbers and
Yes.
you know all of that.
There are studies already with corporal activities related to learning numbers, and definitely if you start to play with the space, you are working on that. Definitely.
There's a dance match game.
Yes.
Where you do a dance match and then they'll hop around each number on in the matrix. And they're to be better addition if they're going forward and better at subtraction if they're going backwards.
Instead of doing maths in their homework in the standing, it was like we're like
But if there's no more questions, thanks a million for a really, really great talk and a brilliant way to end the series this year.